Okay, let's have a go at the paddle steamer question on the Murray River. So we have a paddle steamer, I'm just going to refer to it as a boat from now on. The boat starts in Swan Hill and it goes up to Echuca, and it's a 200-kilometer journey and it takes 20 hours to get there. The boat also goes back and forth to Mildura and Swan Hill. It's 150 kilometers each way, and it's a 22-hour journey in total to go down and up. Alright, so that's our context. We need to find the speed of the boat as well as the speed of the water, and that would be still water. Okay, so 2 parts to this question. What can we work out straight off the bat?
The speed of the boat going from upstream.
Yeah.
This one here.
So we can work out the speed of the boat going upstream, and speed is equal to distance divided by time. So the distance is 200 kilometers. Levi, how many hours does it take?
20.
20. So what's the speed?
10 k's an hour.
Exactly. Alright, so 10 k's an hour is upstream. Okay, so that's upstream. So can we assume that the boat going 10 kilometers upstream applies up here as well as down here?
Yeah.
Okay. It is an assumption, but we'll say that the speed going upstream is still 10 kilometers an hour. So
We can calculate the time.
Yeah,
Because we
going
have the
upstream.
distance from the speed.
yes, we have the distance. So if speed is equal to distance over time, then we can calculate time, because speed is 10 and distance is 150. So t is equal to
Distance over speed.
distance over speed, which is 150 divided by 10, which is 15
Hours.
hours, right? 15 hours. Excellent. So if M to S, all right, from Mildura to Swan Hill, takes 15 hours, then S to N would take,
7.5.
yeah, 22.5, take away 15, which is 7.5 hours. Excellent. So we now have the distance and the time and the speed for
Upstream.
upstream,
We can calculate downstream.
which means we can calculate downstream. Excellent. So let's do that. All right. So downstream distance is 150. Let me write S to N. The distance is 150. Levi, what was the time that it took from S to N?
From S10, 7.5
Yeah,
hours.
7.5 hours. We just worked that one out. And do we have the speed yet from S to N?
No.
No, we don't, but we can work it out now. So we're working out the speed of the downstream. So S is equal to D divided by T, 150 divided by 7.5, which makes
20 kilometers.
20 kilometers per hour. Okay, so if upstream was 10 kilometers an hour and downstream is 20 kilometers an hour, what would the speed be in still water?
Somewhere in between the two.
Yeah.
Is there any way of calculating that?
Well, I suppose we could take the average,
Oh, yeah.
right? And And we can safely assume here that it's going to be 15 kilometers an hour if we took the average. Okay. So that's the speed in still water. And the other thing we needed to work out is the speed of the water. So what would the speed of the water be?
It'd be 5 kilometers per hour.
Yeah, and how did we work out that it was 5 kilometers an hour?
Because if it's going, because you can work,
It's
because
not,
of taking it away from, I don't.
That's right.
really
So
know.
the boat itself, we're saying is going 15. Going downstream, you're going to add 5 to make the 20. And going upstream, we're taking 15 and subtracting 5,
Yeah.
which would make the 10. So it fits, it makes sense. Levi, what were we going to say?
oh, I was going to say.
So let's just write a little conclusion then. The boat travels at 15 kilometers per hour and still water is 5 kilometers per hour. Okay. Now, yeah, let's leave it there.